Now moving on to the 7th bit of 5th problem. He has asked us to prove that sin theta minus 2 sin cube theta by 2 cos cube theta minus cos theta is equal to tan theta. In order to prove this, let us consider the left hand side, that is sin theta minus 2 sin cube theta divided by 2 cos cube theta minus cos theta, that is equal to, in the numerator let us take sin theta common, then we get the numerator as sin theta into 1 minus 2 sin square theta divided by, in the denominator let us take cos theta as common, then we get the denominator as cos theta into 2 cos square theta minus 1, that is equal to, if we write sin theta by cos theta separately, then it is nothing but tan theta into 1 minus 2 into, here we have an identity that sin square theta plus cos square theta is equal to 1, which implies sin square theta is equal to 1 minus cos square theta. Let us substitute it here, then we get 2 times 1 minus cos square theta divided by 2 cos square theta minus 1, which is equal to tan theta into 1 minus 2 times 1 is 2 and minus 2 times 2 square cos theta is plus 2 cos square theta divided by 2 cos square theta minus 1, which will be equal to tan theta times, here by rearranging the terms we get 2 cos square theta minus 1 by 2 cos square theta minus 1. Here in the numerator and denominator we have 2 cos square theta minus 1 as common, which will be cancelled, and finally we are left out with tan theta, which is our right hand side. So here, as LHS is equal to RHS, we can say that sin theta minus 2 sin cube theta whole divided by 2 cos cube theta minus cos theta is equal to tan theta. Now moving on to the 9th bit of 5th problem, he has asked us to prove that cosecant A minus sin A into secant A minus cos A is equal to 1 by tan A plus cot A. In order to prove this, let us initially consider the left hand side, that is cosecant A minus sin A into secant A minus cos A, which is equal to, here cosecant A can be written as 1 by sin A minus sin A into secant A can be written as 1 by cos A minus cos A, which is equal to, let us take here LCM as sin A, then it becomes 1 minus sin square A in the numerator, and if we take cos A as denominator in the second term, then it becomes 1 minus cos square A in the numerator. So whole that will be equal to, we have an identity that sin square A plus cos square A is equal to 1, from which we can say that 1 minus sin square A is nothing but cos square A into 1 minus cos square A is nothing but sin square A whole divided by sin A into cos A. Here if we observe numerator and denominator clearly, sin A cos A gets cancels and it divides numerator in cos A into sin A times. So finally we got the simplified form of LHS as cos A into sin A. Let us also find the simplified form of RHS on right hand side, that is 1 by tan A plus cot A, which is equal to 1 by tan A can be written as sin A by cos A, plus cot A can be written as cos A by sin A, which is equal to 1 by, let us take here LCM as cos A into sin A, then we get the numerator here as sin square A plus cos square A. As we know from the identity that sin square A plus cos square A is equal to 1, and by sending this denominator to top it becomes cos A into sin A. Which is the simplified form of RHS. Here the simplified form of left hand side is equal to the simplified form of right hand side. So the given equation is true. Now moving on to the 8th bit of 5th problem. Let us find the solution for this. Here he has given an equation that is sin A plus cosecant A whole square plus cos A plus secant A whole square is equal to 7 plus tan square A plus cot square A. In order to prove this, let us initially consider the left hand side. That is sin A plus cosecant A whole square plus cos A plus secant A whole square, which is equal to, this is in the form of A plus B whole square and this is also in the form of A plus B whole square. Let us apply the formula that A plus B whole square is equal to A square plus B square plus 2AB. Then we get here sin square A plus cosecant square A plus 2 sin A into cosecant A. Here this can be written as cos square A plus secant square A plus 2 times cos A into secant A. That is equal to, let us write sin square A and cos square A together plus cosecant square A plus secant square A together plus here 2 times sin A times cos A is nothing but 2, as sin A into cosecant A is 2 plus similarly 2 times cos A into secant A is equal to 2, as cos A into secant A is nothing but 1. So finally here, as we know from the identity 1 that sin square A plus cos square A is equal to 1, by replacing it we get 1 plus 2 plus 2, that is 5, plus cosecant square A plus secant square A, which is equal to 5 plus, from the two identities that cosecant square A is equal to 1 plus cot square A and secant square A is equal to 1 plus tan square A. By substituting it here, we get the expression in terms of tan square A and cot square A. That is cosecant square A can be replaced by 1 plus cot square A plus secant square A can be replaced by 1 plus tan square A. That will be equal to 5 plus 1 plus 1 is nothing but 7 plus cot square A plus tan square A, which is nothing but our right hand side. So here we got LHS is equal to RHS, and hence we proved that sin A plus cosecant A whole square plus cos A plus secant A whole square is equal to 7 plus tan square A plus cot square A. Now moving on to the second bit of 5th problem. He has asked us to prove that cos A by 1 plus sin A plus 1 plus sin A by cos A is equal to 2 times secant A. So let us consider the left hand side of given equation, that will be cos A by 1 plus sin A plus 1 plus sin A by cos A. And now let us simplify this, which is equal to, let us take LCM as 1 plus sin A into cos A. Then the numerator becomes cos A into cos A is nothing but cos square A plus 1 plus sin A into 1 plus sin A is nothing but 1 plus sin A whole square. That will be equal to cos square A plus, this is in the form of A plus B whole square, which is nothing but A square, that is 1 square is 1, plus 2AB, that is 2 times 1 times sin A, which is nothing but 2 sin A, plus sin A whole square, that is sin square A whole divided by 1 plus sin A into cos A. That will be equal to, let us write together the terms, sin square A and cos square A plus 1 plus 2 sin A whole divided by 1 plus sin A into cos A. Now we have an identity that sin square A plus cos square A is equal to 1. Let us substitute that. Then it becomes 1 plus 2 sin A by 1 plus sin A into cos A, which is equal to 2 plus 2 sin A divided by 1 plus sin A into cos A, which is equal to, let us take 2 common in the numerator, then we get 1 plus sin A by 1 plus sin A into cos A. In the numerator and denominator, 1 plus sin A is common and that gets cancelled. Finally we are left with 2 times 1 by cos A, which is equal to 2 times, we know that 1 by cos A is nothing but secant A. Here finally we got 2 times secant A as answer. Then which is nothing but our right hand side. So here LHS is equal to RHS, and hence we proved the given relation between the trigonometric ratios.